Okay, we're going to take a look at section 8.1, which deals with integrals as net change. So you should have these notes. I think I gave them to you. I'm also going to do, after we go through this PowerPoint, I'm going to do some examples from your textbook that will be similar, of course, to your homework problems. So suppose there is a honeybee who makes several trips from the hive to a flower garden. There he is. The velocity graph is shown below. So here we have a velocity graph. And I've mentioned this before, this is very typical of what you could see on the AP exam would be a velocity graph and then questions about both things. So, so this tells you from 0 to 2 minutes, the little bee is going 100 feet per minute. And then from 2 to 3 minutes, he's at 0. And then from 3 to 5 minutes, he's going negative 100 feet per minute. So you can see that sometimes it's positive, sometimes it's negative, and you got to think about what that means. Remember that if he is a positive velocity would indicate that he was moving towards the away from the hive and towards the flower garden. So it's telling us the direction. So keep that in mind. So now we're asked, what is the total distance traveled by the bee? So the distance we can actually find underneath the velocity graph. So the area under the curve. So we would get 100 times 2, so 200 feet would be a total distance as he's going from the hive to the flower garden. And then we have another distance of 200 as he goes from the flower garden back to the beehive. And then we have another 200 feet as he makes another trip. And then he only travels 100 feet, which means he does not make it back to the beehive. So maybe somebody kills him. I don't know. Don't want to think about that, huh? So anyway, we can see the total distance traveled by the bee would be, if you add all those up, the total distance would be 700 feet. So the bee has traveled 700 feet total. However, you can also talk about what is the displacement of the bee. So where does the bee end up in relationship to where he started? And I suppose I shouldn't say it's a he because well, wait, are all worker bees he's? I don't know. Somebody can text me that or email me that. So the displacement of the bee, so if he travels 200 feet, and then now we have to think of this as negative 200 feet because he's going back. So at this point right now, his displacement is 0 because he went back to where he started. Then we have a positive 200, and then he only goes part way. So then we have a net displacement of 100 feet. So he is 100 feet from the hive after 10 minutes. So you do need to know the difference between if you're being asked for the distance, the total distance, or being asked for the displacement. So to find the displacement, which is that position shift from the velocity function, we just integrate the function. Just straight integrate it. The negative areas below the x-axis subtract from the total displacement. So you don't have to worry about anything. You just do an integral. So that's displacement. So the displacement, you could go from A to B of your velocity function, and that would tell you the displacement. If you want to know the total distance, all you have to do is use absolute value. So that is just going to give you that information. If you didn't use absolute value, you would have to find all the places where the zeros were, and then all the ones that were below the x-axis, you would have to change the sign. But if you can do this with absolute value, definitely the easiest way to go. So find the roots of the velocity equation and integrate in pieces. So that was what I was just talking about. Just like when we found the area between a curve and the x-axis, take the absolute value of each integral. So if you needed to do that, if you were working on that by hand. Using your calculator to integrate absolute value is totally easy. So if you are doing this on a calculator section, which this year, your AP calculus exam, you're going to have your calculator available to you all the time. So that kind of changes things a little bit. So here I have a velocity graph. And we want to find the displacement. So it looks like we don't have any context this time. So from 0 to 1, you can see the area. You can find the areas of these pieces because we don't have the function. We don't need it because they're all straight line pieces. So we have, rectangles and triangles, trapezoids. So you can just find the area of the pieces. So we have an area of 1. We have an area of 1/2. This would be an area of 1/2. And here we have an area of 2. So if you want displacement, remember that's when it matters if it's positive or negative. So we have a 1 plus 1/2, then minus 1/2, minus 2. So our net displacement would be -1. Notice there is, if you look at this graph, notice there's more underneath the x-axis than there is above. So that makes sense that we have a negative displacement. If you want the total distance traveled, you just take all those as positive values and add them up, and you get 4. Okay, so again, make sure you know the difference between displacement and distance traveled. So how could we get our position graph from that? Well, remember, if this is the velocity graph, then the position graph, we know that, so we're kind of working backwards from that. So we have we have a slope of 1 from, hold on here. Okay, just wanted to make sure, wanted to kind of go back and make sure I wasn't saying the wrong thing. Let me kind of forward it back up to where we were. Okay, so for this position graph, the velocity right here is 1. So notice from 0 to 1, we have a slope of 1, okay? Then you can kind of see my velocity is positive, and then when I get to x equals 2, it changes to negative. So that tells me that there's a max at x equals 2, so we can see that. So remember, when we look at the velocity goes from positive to negative, which means the position is at a maximum right here. And notice from 2 to 3, we actually have, we can, well, this one, not as much, I guess, to see there, but we do know from 3 to 5 that the slope is -1. And notice from 3 to 5, you have a slope of -1. So you can kind of get clues from the velocity and relate that to the position. Now, I know all bets are off here this year. Every AP exam I have seen, and this really is true, they give you a velocity graph because looking at the slope of the velocity graph is the acceleration, and looking at the area under the curve of the velocity graph is position. And so it's a great problem to ask both types of questions. This year, not so sure, because it's kind of hard to predict since there's only going to be 2 free responses. But but this is a good concept to know. In the linear motion equation, we know that, and I might go through this part kind of fast, the derivative of position is equal to velocity. So we know that. We've dealt with that before. So separating the variables for and you can kind of read through those, you have the notes. So if we do separation of variables, and I just want to kind of get to this part because this is just going the other way, and I just want to briefly talk about that. Because this is really the part we're after right here. Whoops. Sorry, you guys. Okay, this part right down here, that to find the position, we integrate velocity. So this kind of was the key part right from here. The derivative of velocity is position, and the integral of, I said that backwards, the derivative of position is velocity, and the integral of velocity is position. So it's just the antiderivative. There are other types of problems where you can use this same idea. So suppose you are talking about the national potato consumption. The rate of potato consumption for a particular country was C of t equals 2.2 plus 1.1 to the t power. Now, where t is the number of years since 1970, C is in millions of bushels per year. So for a small amount or small change in time, the rate of consumption is constant. The amount consumed during that short time period, what we're looking at is this right here. Now, how do you know when to integrate? If they give you a rate, if this is the if this is the amount of potatoes consumed per time period, per year, then that's a rate. Potatoes consumed per year. So if you want to know the number of potatoes, then which would be the total consumption, then you integrate the rate. So you can, a lot of times you can tell what to do in a word problem by looking at the units. Do they give you a rate and they ask you about like the pounds of potatoes, and then you know you're going to integrate that. So from the beginning of 1972 to the end of 1973, that would be a 2-year time span. From, notice it's the beginning of 72 to the end of 73, that's 2 years. So over that time period, if you integrate that, and you can do the antiderivative, or if you were allowed to use your calculator, you could do that, and we get 9.066 millions of bushels. So I'm integrating a rate, so now I'm left with the amount of potatoes. And that was the end of that, and now we are going to do some examples from our textbook. Okay, so for the first one, I'm doing problem number 2, and we are given the velocity in meters per second of a particle moving along the x-axis. We have to use analytic methods to do each of the following. So we need to first determine when the particle is moving to the right, to the left, and stopped. Recall that it's moving to the right. So it's moving to the right when v of t is positive. It's moving to the left when v of t is negative, and it's stopped when v of t is 0. So that's what we have to determine first. And our function is 6 sine 3t, and we're given this for our domain. So we need to know, when is this positive, when is this negative? Well, 6 sine 3t is positive when sine 3t is positive. Okay, well that should make sense. Think about the unit circle and when sine is positive. Sine is positive in quadrant 1. All students take calculus. So sine is positive in quadrants 1 and 2 and negative in quadrants 3 and 4. So that means it's positive from 0 to pi. So we need to know, so when 3t is between 0 and pi, strictly positive, not 0, so I should do that. So that means it's between 0 and pi over 3. So I'm dividing each part by 3. So we actually were given as our domain 0 to pi over 2, and that falls within that. So so our answer for when it's moving to the right, so moving to the right when 0 less than t less than pi over 3. And our 0, so it's stopped. We want to know when this is 0. So remember that sine is 0 at 0 and at pi. So when 3t equals 0 and when 3t equals pi. So at t equals 0 and t equals pi over 3, so stopped, it can be 0, it's within our domain, so stopped when t equals 0 and t equals pi over 3, so then it must be moving left because we have to go up to pi over 2, so when from pi over 3 less than t less than pi over 2. It would be moving left. Now, how could you do that on your calculator? Suppose we graphed, make sure, by the way, that you are in radians, and suppose you graphed y equals 6 sine 3x, and I'm going to adjust my window from 0 to pi over to pi over 2, and let's just take a look at that. Okay, so notice that it is positive And I'm guessing like if I do second calc 0 right here, let's check it out. Second calc 0, and I'm on the left, so that can be my left bound. And this can be my right bound, and my guess, 1.047, which you can check, but that is approximately pi over 3. So you can see that it's positive between 0 and pi over 3, and then it's negative, and you can see your zeros. So you could do this on your calculator. Okay, so for this next part, for part B, I'm going to go ahead and talk about how you would do this using a calculator. I know it's not, I know it's shaded. Find the particle's displacement for the given time interval. And then if the initial position is 3, what is the particle's final position? So the displacement, remember to find displacement, we do the integral. We don't do absolute values. So we're going to do the integral from 0 to pi over 2 of 6 sine 3t dt. So we can finite that. So if we do that, so we have from 0 to pi over 2, and we've got 6 sine 3x dx. So we get 2. So that would be the displacement. But then they also say if s of 0 is 3, so if the initial position was 3, then what is the final position? So we're going to have to take, he starts at 3. Is that what it just said? Starts at 3 plus the displacement to get the final position. And then part C, find the total distance traveled. So to get the total distance traveled, we're going to still integrate from 0 to pi over 2, but this time we're going to do the absolute value of 6 sine 3t dt. So let's see if I can do it this way. I don't think so, but let me try. I'm going to insert absolute value. Oh, that's not going to work. Okay, I'm going to pause this. Okay, so I went through and did this. I had to kind of go back and redo that. Now remember that your calculator, when you do finite, it does approximate. It uses a little bit of rounding. The answer really is 6, and correct to 3 decimal places, you would get 6. So that is the total distance that the particle would travel. That's what you do to answer one of these questions. I think I assigned number 1. I really don't mind if you use a calculator. Honestly, on number 4, on numbers 3, well, definitely 5 if you do that one, use a calculator. That's fine. But you should still understand the concept behind it, even so. So I had originally planned on doing numbers 4 and 6 as well, but I just don't want this video to be like an hour long. So if you need me to go back and do some more, just let me know and I will. So for this one, a particle travels with velocity, and we're given this function for t is between 0 and 4 seconds. What is the particle's displacement? So remember, for displacement, it's just the integral. So we're going to have the integral from 0 to 4 of v of t dt. So it's going to be t minus 2 sine t, and that was in meters per second. So we're going to put a dt here. So we're just integrating the velocity, and that's going to tell us the displacement. So as a matter of fact, I'm not even going to do this because you would just finite this. Part B, to get the total distance, you're going to go from 0 to 4. The only difference is you're going to have the absolute value and get your answer. Oops, sorry. And then get your answer for that one. Okay, so just remember displacement, distance, which one you do. Now remember, they can also ask you, where do you end up? Like, where's your final position? And that you would have to know the initial position, but that can happen as well. So numbers 12 to 16 kind of go together. If a particle moves along the x-axis in centimeters. Its initial position at t equals 0 seconds is 15. So we know that x of 0 is 15. So we're given that. The figure shows the graph of the particle's velocity. The numbers are the areas of the enclosed region. So they already give us those values. So number 12 asks us, what is the particle's displacement between t equals 0 and t equals c? So the 0 is right here. So we want the displacement. That means we care about the sign. So for displacement, so we have a -4 plus a +5 plus a -24. So we get -23 for our displacement. And that would be centimeters. And we actually, because this is v of t right here, if we needed to show a symbol for this, we could say we're integrating from 0 to c of v of t dt, because that kind of shows that we understand what it is that we're doing. So that's 12. Number 13, what is the total distance traveled by the particle in the same time period? So the total distance, we're going to take the integral from 0 to c of the absolute value of v of t dt. So now we're going to have 4 plus 5 plus 24. So we get 33 centimeters. Okay. Number 14. Give the positions of the particle at time A, B, and C. Well, remember that x of 0 is 15. That's where it started. So at time A, it started at 15 and it went back 4. So the position would be at 11 centimeters, or just 11, because we're on the axes. So we're not talking about a distance this time. So it's at 11. Then at time B, so it went from 11. So at A, it was at 11. So we can just go from there. 11, and then it's going to go 5 more in the positive direction. So it's going to be at 16. And then at time C, it was at 16 and it went back 24. So that means now it is at, what would be now? -8. Okay, so you can kind of show how you would do that. Number 15, approximately where does the particle achieve its greatest positive acceleration on the interval from 0 to b? So now we're being asked about acceleration. So we have to look at the velocity graph and say, well, what does this have to do with acceleration? So we need to be looking at the slopes of this, and we want the greatest positive acceleration. So we are looking for where it has the greatest positive slope. That's going to happen where the graph is the steepest in the upward direction. So that's what you want to be looking for. Okay, so I was just noticing this is just from the interval 0 to b. So looking from 0 to b, it has the steepest positive slope right here at A. So for that, it's going to be at A, and you can give a reason. It has the steepest positive slope. And then for number 16, now we're on the entire interval. Same question, but the entire interval. And you can see here that that's going to be at C. So that's where it has the steepest positive slope. Okay, so here's number 20. And the velocity of a particle is, this represents the velocity of a particle moving on the x-axis. And they give you an initial position. The particle starts at x equals 2 when t equals 0. I actually added these in. I found the area of the triangle, the area of the trapezoid, the area of the triangle, and find where the particle is at the end of the trip. So notice that this is displacement. It doesn't say the word displacement, but it is. But it's more than just displacement because it is initial position. Actually, let me move this. So it is initial position plus displacement. So remember the initial position was 2, so it's 2 plus the integral from 0 to 10 of v of t dt. So it's always good to have the symbol there. I'm guessing this is even going to be more true this year, although it's always true, to have the symbol so it's easy, so you can see this is what you knew to do to find the integral, even though you wouldn't necessarily need it, because you're not integrating the function, but this makes sure you are showing that you understand that. So then we get 2. This time I'm paying attention to positive or negative, so we get plus 3 minus 12 plus 4.5. So we get negative 2.5. That's where the particle is at the end of the trip, so we can just leave it there, negative 2.5. Find the total distance traveled by the particle. So this time I don't need the initial position. To find the total distance traveled, I'm going to take the integral from 0 to 10. And I want total distance, so I don't. I need to do the absolute value of v of t dt, which means I'm going to take 3 plus 12 plus 4.5. So I get 19.5. And this time I need the units because I'm talking about how far, so that's going to be in meters. So that would be my answer for the total distance traveled by the particle. Okay, so this one, the rate at which your home consumes electricity is measured in kilowatts. If your home consumes electricity at the rate of 1 kilowatt for 1 hour, you will be charged for 1 kilowatt hour of electricity. Suppose that the average consumption rate for a certain home is modeled by the function. So this function right here, they're telling you, is the average consumption rate. So it's a rate. So you want to pay attention to that. Where C of t is measured in kilowatts and t is the number of hours past midnight. Find the average daily consumption for this home measured in kilowatt hours. So we are looking to find, we want to integrate this so that we can find the average daily consumption. So we're going to integrate from, so we are doing a 24-hour period, right, for 1 day. So 0 to 24, and it's in hours, so we have to go 0 to 24. And then we'll have 3.9 minus 2.4 sine pi t over 12. I'm going to put some brackets here, dt. Then you can actually go to your calculator. Okay. You can punch that, just be careful with, parentheses and all that kind of stuff, but you should show that you can get 93.6, and that would be in kilowatt hours. So hopefully that gets you through your assignment. You actually have an additional day on your assignment, but I'm posting it today anyway, so that it is not due though until Thursday. Is that right? Yeah, that's right. Okay, so so that gives you a couple days to work on that assignment. If you guys need me to do any more problems, please, please, please send me a message. Let me know. I do get if you put a personal comment on an assignment, I do get that in my email right away. Well, when I check my email. So I would be happy to do a video with more examples. Just let me know.